Thank you, and welcome to everyone who's joining us today for the next in our Educator Effectiveness webinar series. Today, we'll be addressing the topic of mathematics instruction in the Common Core and answering the question, where do we go from here? Again, I'm Elizabeth Greniger, your webinar facilitator. Joining me today, we have Dr. William Schmidt from Michigan State University. Before I do a formal introduction of Bill, I want to take a few moments to find out who's joining us today. In a moment, you'll see a poll come up on your screen, and I'd like you to select the response that best fits the role that you serve in. My hope was that we'd have lots of school-based folks joining us today because I think that the information that you'll hear will impact your mathematics instruction in classrooms. But it's also great to see lots of other folks joining us. Bill has a wealth of experience to share with us that will impact both the classroom all the way up to the policy level. So we'll get into a lot of great conversation today about the way that this topic can impact all of your work. Wonderful. Glad to have you all with us. And now I'd like to introduce our presenter for today. Dr. William Schmidt, otherwise known as Bill, is a University Distinguished Professor of Statistics and Education at Michigan State University. He serves as the co-director of the Education Policy Center, and he holds faculty appointments in statistics and education. Previously, he served as the National Research Coordinator and Executive Director of the U.S. National Center, which oversaw participation of the United States in the IEA-sponsored Third International Mathematics and Science Study, known as TIMSS. He has published in numerous journals, including the Journal of the American Statistical Association, the Journal of Educational Statistics, EEPA, Science Educational Researcher, and the Journal of Educational Measurement. He has co-authored 10 books, including Why Schools Matter, Teacher Education Matters, and Inequality for All. His current writing and research concerns issues of academic content in K-12 schooling, including the Common Core state standards for mathematics, assessment theory, and the effects of curriculum on academic achievement. He's also concerned with educational policy related to mathematics, science, and testing in general. Bill holds a BA in mathematics from Concordia College in River Forest, Illinois, and his PhD from the University of Chicago in psychometrics and applied statistics. He was also awarded an honorary doctorate degree from Concordia University in 1997, which is among several other awards and honors that he's received. At this time, I'd like to introduce you to Bill Schmidt.
Hello, everyone. It's my pleasure to be here today to share with you much of what we have learned over the last several years in looking at the Common Core since its inception, and in fact to take you back a little bit to what kind of work and research actually led to the development of the Common Core. And before I begin and talk specifically about the Common Core, I wanted to just remind all of us as to why it is so important that we do have the Common Core. I think sometimes now that we're in, and it's been some 4 or 5 years, that people may just sort of forget what the motivation and the driving force was to having this thing called the Common Core in mathematics. And I just remind us in terms of something that fairly recently lets us know just how important this is. In the year 2012, PISA did the study, the most recent international study. And if we look at those results, which came out about a year or so ago, we find that the United States on a literacy test, which is different from what TIMSS does, which is more of an academically oriented math test, but we find in a literacy sense, which is so much more the focus today, that we, as a nation, on average, perform 27th out of 34 countries. Those 34 being the OECD countries, the major economic and wealthy nations, economic partners in the wealthy nations of the world that we mostly deal with in multiple ways. So that reminds us again that what we have been doing, what was the set of standards that we had previously at the state level, and all of that never really did work very well for us. And I think when you hear people being critical of the Common Core, sometimes I want to say, well, do you remember what things were like before we went on to this and developed this Common Core set of standards? And I think it's important to remind ourselves every once in a while of exactly why we are where we have been. Let me just take you through a couple slides which I think helps remind us of what all this is about. There are two roles that the Common Core state standards in mathematics serve. One is to help develop excellence. That with the citation I just gave you about being 27 out of 34 reminds us of the fact we do want to increase the performance of our students from an international perspective, and even in terms of our own national assessment. We're not satisfied where our students mostly fall. And toward that end, I have some good news to come and share with you in terms from the PISA study. In that study, again, it was a literacy test, and it has to do with the solving of real-world problems around quantitative thinking. So this is a very important measure when you consider the fact that the Common Core standards have also been called college and career ready, which implies that we want students, no matter which major should they go to college, or no matter what profession they go into, that they be quantitatively literate, that they have a mathematical set of languages by which to address the increasingly quantitative type problems that we encounter in the real world. And that's the PISA test. So it's an important indicator of where we are with respect to a goal like college and career ready. This slide shows you not the performance, but it shows something very important because it really makes the point that schooling matters. What you have here is for each of the countries, and actually these are all 62 countries, what you have is to show what the relationship is between exposure to mathematics, formal mathematics in the school, what relationship that kind of schooling has to performance on the PISA test. The black line that you can see in the middle of the display, this orders the country from the bottom are those countries where there was not as strong a relationship of the exposure, the opportunity to learn, if you want to call it that, and performance, to the top, where the top countries are the ones in which the relationship of the curriculum, the exposure to mathematics, is the strongest. You can see the black line, which is the average across the OECD countries. And just to give you a sense of that, what that means is that's over a year's worth of difference. That is exposure to more of this mathematics that we call formal mathematics. And that increased exposure is really amounts for about a year's worth of difference between in terms of students at one level versus students that have 1 unit higher in terms of that exposure. So that's a lot of difference. If you look at the yellow arrow up there, that is speaking to the United States. And you can see we are a country in which the relationship of that exposure to mathematics is the strongest. So this tells us that what we do in the curriculum is very important to what children learn. And even with literacy, where sometimes people want to suggest that, well, you don't need all that formal math that the Common Core calls for, what this set of relationships show us is, yes, you do need that. That is what this clearly says, is the amount of exposure to formal mathematics is absolutely critical to even a literacy test. And so we see evidence to support the Common Core's more formal treatment of mathematics that we have now in our curricular our standards, our curricular expectations. There's another way in which this enters the picture, and that is we also measured in that same PISA study the amount of exposure students had to applied problems. That is, how much in their instruction and in the tests they took did they actually see problems which required them to apply the mathematics to real-world situations. And what you can see with this set of curves that you have here is, unlike the formal mathematics, applications, they do have they are related to an increase in the performance on the test, but only up to a certain point, after which further exposure essentially is a downward relationship. That is, it's negative. Too much applied mathematics, too much exposure to these kinds of problems, in fact, is not necessarily good. So we have a nice picture now to know that what we need to develop this kind of literacy, this quantitative literacy so necessary in the 21st century, is that the amount of formal mathematics is very strongly related, and exposure to applied problems is also, but only to a certain point, after which it is actually somewhat detrimental. Probably because of a trade-off. That is, the more of that you do, the less you would put perhaps into the more formal aspects of mathematics. So these give some ideas that clearly the kind of things that the Common Core is calling for, because they are more competitive as a set of standards to what other countries who do very well do, that we've moved in the right direction toward the goal of excellence. But there's a second goal with respect to the Common Core, and that is equality. That is, that we want to have all children be able to be exposed to the kind of mathematics that would improve their literacy and hence their being college and career ready. This is a study we released yesterday, so these results are real. Some of you may have seen it. It was in some of the papers like the Washington Post. And what we found in that work, and this is again using the same piece of data that I referred to a few moments ago, is that when we talk about the SES inequality, that we know that children from lower SES homes score much lower on this kind of a literacy test. In fact, we estimated it than do the richer kids. And we found that that SES gap is almost a full standard deviation, which is over 2 years difference. Translation, that the kinds of the performance of the low SES kids is about a couple years behind that of the performance of the higher SES kids. So we know there is that SES inequality. It's true in every country in the world. What you see in this slide that's sitting before you is that the bluish area shows the SES inequality in that occurs from the home in the background. So if you look at that, that sort of ranks the countries. That shows that it goes from countries like the Slovak Republic, etc., where the amount of home-based SES inequality is among the strongest. The red that you see on the top of the blue actually then shows the amount of inequality that results from schooling itself. Because who gets to study which kind of mathematics varies by social class, that's what that red part refers to. It's what we call the indirect effect. The red is the schooling inequality, the blue is the home, family, background inequality. We are having a difficulty at the moment.
Bill, can I jump in? Do you want me to advance the slides? Would that be helpful?
Yeah, that would, because what's happened right now is we've lost, and there's a big echo, and our whole screen just went dead on us for a minute.
Okay, no worries. Take just a moment to get yourself
back now. Sorry about that,
okay.
Folks. So what I was saying, I don't know at which point you could no longer hear me, but basically, let me just quickly state that this slide shows the amount of SES inequality related to performance on that literacy test. The blue, which is what structures this graph from the most to the least, is the home, background, family, economic capital, cultural capital that comes mainly from the home and the family background. And you can see that there's quite a variation across these, with Israel and Slovak all the way down to Mexico and the Netherlands. But what the red indicates, that sits on top of the blue, is the amount of inequality that arises because schools do not give the same opportunities to children of different social classes. In other words, the red represents the schooling, the inequality, the SES inequality that results from schooling not assuring that all kids get the same opportunities with respect to the mathematics that they study. And so you can see for the OECD on a whole, it's about a third of the inequality is added by that schooling inequality. In the United States, it's almost 40%. It's actually 37%. So you can see here that when you add that school-based inequality, it really distorts the sort of the rating, the ranking, the order of the countries when you only look at the home and family background inequality. So what this really says, and this is where the Common Core comes in, is the word common. The whole other goal of the Common Core is to assure that all children receive the common set of standards, operate by those standards. That, in other words, the distribution of the coverage of mathematics is not related to social class. If we were to accomplish the goals of the Common Core, if we were to actually remove that red that you see on the slide for the United States, you would make us, if you can see where we are in this slide where the yellow is, we're not that high up in terms of inequality. We only become that as we add the additional 37% that comes through our schooling. But you can also see we're not that atypical. Across the world, most countries have this high degree of inequality that's coming through their schools. This is a really startling finding. And I ask you to keep this in mind as we go through this, because that is one of the goals of the Common Core. When hopefully, if it's properly implemented, it should begin to reduce that red bar that you see that's added to the U.S. Social class inequality. One way to make this point really quickly, if I were to say to you, which country do you think is more equitable from this point of view, Sweden or the U.S., you would suggest most likely Sweden. Well, if you look and find Sweden there, they're only about the fourth one over on the far right. And you can see that they actually, from a home point of view, have more inequality than we do when you compare it to the yellow. But then there is nothing added with respect to inequality of schooling. Their system of schooling is equitable. We, on the other hand, add 37% so that in the end they are more equitable than we are, but only because of the inequality that we contribute to our system through the schooling inequalities. Well, that sort of sets the basic essence of what the real issues are, I think, as we talk about this Common Core. And so where did the Common Core come from? Well, the research that was done on TIMS, which was mentioned earlier in my introduction of myself, and that is that we found in that research, we did the study of standards and textbooks and found there are three characteristics, focus, coherence, and rigor, that distinguish the standards of countries whose students did quite well and those of the United States and other countries who did poorly. Focus has to do with the mile wide, inch deep that we simply tried to cover so many topics at each grade level. Rigor was the fact that by 7th and 8th grade in most of the advanced countries, all children, and I underline the word all, were studying algebra and geometry. Coherence was the most important of the three, which said that mathematics has a structure, an underlying structure which is hierarchical. And those countries that did well, their standards progressed in that fashion, reflecting that internal logical structure of mathematics. And what we in the United States had was a collection of topics not reflecting that kind of structure, and thus producing a rather incoherent sort of version of mathematics instruction. Well, the new standards in the Common Core essentially have recognized these three principles, and they were the guiding principles behind the development of the Common Core math standards. And we did a piece of research in which we found that basically there was about a 90% overlap between the new standards and the worldwide standards that we found. We called it the gold standard when we looked at those standards of those countries that did particularly well. Secondly, which I think is important, we actually looked at the states in 2010 and the standards they had. And we asked, were those states whose standards were the closest to the Common Core, how well did they do on the NAEP, math scores, the state NAEP scores. And the hypothesis, the notion was, if those states whose standards were closest in substance to the Common Core did better on NAEP, then that in fact would at least be a suggestion that we were moving in the right direction. It wouldn't prove anything, but it would at least indicate a movement in where it seems like we should be going. And that's what we found. There was a strong relationship between that degree of similarity and the performance on the NAEP test. So what are the goals of the webinar that we hope to accomplish through this conversation? First is to look at what the Common Core state standards, what difference do they make in terms of the actual mathematics that's being covered? What kind of things can we look at and know from research that might influence and help us in the instruction of that? And how that implementation, if done properly, could probably improve the student learning. And I just cited to you a piece of research in the previous slide that shows that in fact we do have some evidence pointing, not necessarily proving, but pointing in that direction. Now what about these Common Core state standards in math? What are they like? Well, they vary by content and grade level compared to the traditional math standards, but one thing I can tell you, they're definitely much more focused, and they are much more coherently put together. They're driven by research. I cited to you a moment ago what research did that, and I think that this is the basis we have. So let's talk a little bit more about that Common Core. What is it like? Well, as I said, they're fewer, they're clearer, they're more demanding, they're more rigorous. They are lined up with what businesses have suggested is necessary in many careers. We know that these are also lined up with what colleges generally expect. But this is the point I made earlier, that in that sense, since this is a general statement, not for math majors or work related to mathematics, some might say, well, what does that mean? I think what that means is literacy, so that you have a decent enough understanding of quantity, space, shape, relationships, that you actually can look at and understand problems that are quantitatively phrased. And I think more and more that is the nature of the work in the world, even in fields that you wouldn't think like marketing research and things. There's so much driven now by, in politics, there's so much driven by data collections and surveys and understanding statistics and knowing how to interpret and think quantitatively. Also, the Common Core standards they're driven by coherence. So there are certain progressions that are implied by those standards which then help to understand that deeper structure of mathematics. And the more that you understand that deeper structure of mathematics, the better you are at being quantitatively literate. The better the chance that you have to do higher order thinking. They're internationally benchmarked, as I mentioned just a moment ago, and they're solidly based on research. When you hear people say that a group of people just made these up, well, that's just somebody's fabrication of what the reality was. I say that as a first-hand observer, since it was the research that we were involved in, and I was also involved at different stages in looking at these standards. So I know they were based on research and evidence, whatever was available. This is just suggests to you that the order was the standards preceded and then the progressions, but the progressions were always in the mind as these standards were being put together. And this whole thing was done with the input of teachers, content experts, in other words, mathematicians, and scholars, researchers who had the background in studying and looking at these kinds of issues. But there's one other really important aspect of the standards which I think are so central but yet so misunderstood and so poorly implemented that I think it is one area that really deserves more research, more work, more understanding and in order to really implement these standards appropriately. And what I'm talking about is these math practices are not a list of 8 things that you should do and like a check-off list and say, well, I did 1, I did 6 or whatever in this lesson. This is a way of thinking. the word that I like to carry, this is like the zeitgeist, the spirit of mathematics. It is the essence of what it means to do and understand mathematics. So these just characterize what should be the actual spirit, the zeitgeist of the classroom in which the Common Core is being properly implemented. Bill McCallum, one of the authors of the standards, put together this little slide which shows how they can be grouped. And you have the green, which is the reasoning and explaining, on down to the 7 and 8, which are seeing, structure, and generalizing. This is an appropriate way to think about this. But what worries me, and we've done some recent research on this, we actually have studied teachers and we've videoed over 140 lessons, and we then have coded the presence of math practices. And I will tell you, sadly, that the teachers split in that we had. We had about 50 of the lessons were really pretty much characterized by not much math practice being done, not many math practices or any of them being done during that period of one lesson, to the other group which did them. And so we have a dichotomy as to how much it's being done, but also secondly, there's a great deal of misunderstanding on the part of teachers as to what these are and what they should do. Part of that research, we also looked at what was available on the internet and the web systems, and we found very often that what was being used as an illustration of math practice 4, just to pick one, was actually about every other math practice but 4. And so we found that there's a great deal of confusion, I think, because this is the one insight that I think we've gained from some of this work, and this is the problem. These practices are beginning to be somewhat separated and removed from the content of mathematics, which is not what they were intended to be, and it is certainly not what they should be. And I think this is an area that really demands further work toward understanding, improvement of defining what these are, and finally helping teachers to better understand that so they might implement those standards in their instruction. Here's a problem, and I think just for some of you that may not have looked at this math thing, is that the problem here is in two versions. More traditionally in the U.S., we might say which fraction is closer. The second way actually then tells them the answer, if you will, but then asks them to demonstrate this by putting on the number line. Well, a lot of parents, as I listen to what's said often in my own local situation here in East Lansing, a lot of parents will say, well, that's what's wrong with this. These kids, why do they need to do that number line business? I mean, you can just figure that out from 4/5 and put it to a percentage and 5/4 and figure out which one's closer. But that's not the point. The point of this is to understand that these are numbers. These rational numbers, these fractions, belong on the same number line that 1, 2, 3, 4, 5 do. And that in fact it's through that understanding of being able to relate it to the other numbers in the system and relate numbers, rational numbers that are just expressed in different ways, and still find them on that number line. In that way, they have a sense of number that transcends the particulars of whether it's number, whether it's a fraction, whether it's a decimal, whether it's a rational, whether it's an irrational number. Those things can make some sense when it's related to the continuum, the number line by which you can place the numbers. So that gives you one sense of how this is done. And we've talked a little bit about this already, of what literacy is. The only thing I want to add, you can self-read this, but basically one of the ways that PISA thinks about this, which I think is so productive, is that you come to a problem that you need an answer to. It might be a problem of how much carpeting do I need to redo my living room. Then you have to formulate that problem mathematically. That's the first phase in this literacy approach. And it is probably one of the hardest, as you take from the problem the context of what you're trying to find and formulate it in a way that is mathematically now a problem. Because once you do that, then the second stage is simply to formulate, not formulate, but to actually compute the mathematics, which is the easiest part. If you know the mathematics, you just figure out the answer once you've properly phrased it. Set up the equation, built the model, whatever needs to be done. And then finally you interpret that back to the real world. And that's really what this is saying, is that's what literacy is. And that requires something beyond just straight knowledge of the algorithms and the facts of mathematics and number, but it really requires you to be able to reason with it. And that's really what the Common Core is all about. And it's that thing which is so much more critical in today's world that I think bothers parents, as they then cannot see why this just doesn't, it's not the computational part, they want the problem already formed mathematically and then they just solve it. They know what 6 times 5 is. But they'll get to the point where you recognize that 6 times 5 is what's relevant to the problem you're addressing, and then reinterpreting it back. That's where the literacy aspect comes in. My favorite part on the interpreting is just an illustration. You ask kids how many buses you need. If each bus holds 10 people and you have 32 people, they'll say 3.2 buses is what you need, not realizing that when you take it back to the real world, if you have beyond the 30 that would fit in the 3 buses, you need a 4th bus. There's no such thing as 2/10 of a bus. So that's kind of where we're going. Some of the previous standards, these comparisons, as I mentioned earlier, there are fewer of them. They're more coherent, and they really work on this conceptual aspect of understanding this. And how do standards work? Well, they should drive the classroom instruction, which then should impact student achievement. But the thing that's missing on this, and we'll talk about that in a few minutes, because this is one of the things teachers have to deal with, is that the standards should impact the development of the textbooks and the instructional materials, which then are used in the classroom by the teacher toward developing student achievement. And that's the part that we'll talk about in just a few minutes. So back to you, Elizabeth.
Great, Bill. Thank you for that really wonderful introduction, not only the background of the Common Core, but some of the precursors and why we are where we are today. I think that was really helpful in understanding really the groundwork that has gotten us to this place. So now we want to kind of open it up to our participants and think about how have the Common Core state standards changed your views of standards and instruction in mathematics. And we'll have a secondary question also up on the screen. What does it mean to be a literate person in mathematics in the 21st century? So we just saw a slide that has several points to respond to that question, but we're interested in finding out from you in the work that you do, how being literate impacts your students or the work that you do. So those 2 polls will be coming up on the screen. And while we give you a few minutes to respond to those, we'll take a look at the parking lot. I do see one question from Edward, and this refers back to slide 16, I believe. One of the mathematical practices, use appropriate tools strategically. Bill, Edward's wondering if you can elaborate a little bit upon that particular practice and talk about when it might be appropriate to use certain types of tools.
Well, the Common Core standards actually have a position on this, and I think the general position that I would have is that certainly in the early grades, students need to develop a proficiency, fluency is probably a better word for it, with respect to certain of these basic fundamental things that one needs to do. And after a certain point, when that's fully developed and everybody can quickly say 7 times 6, and they can then take 77 times 8 and do that relatively quickly. That is then when these basic algorithmic skills fall into place and they're known, then I think it's quite appropriate, and especially toward the upper middle grade, upper middle school and into high school, that for most of that work, the calculator is much faster, much more accurate, but again, being an academic and a university, I have PhD students in statistics who I send off to do an analysis, and they come back with it, and done on the computer, and there's an answer that's just wrong. You can see it within 3 seconds. And they all look at me, how did you figure that out? Well, how I figured that out is because I know those basic algorithmic skills, and so I can approximate what the answer ought to look like, and when it's way off, then you can know that somebody must have, entered the numbers wrong or did something wrong. And I think you have to get to that level of being facile with the algorithmic skills before it's really good to start using calculators and things of that sort.
That's really helpful, Bill. As I'm glancing at some of the comments, and I see Sierra posted in the parking lot, but also others who are posting in response to the question we have on the screen, excuse me, I'm seeing a few elementary folks coming through. And one of the things that they're saying is that Common Core has really changed their focus at the elementary level. What have you seen in the work that you've done with respect to that deeper focus in the elementary grades?
I think that's a very correct insight. I mean, we often, some of the things that people have misinterpreted, I believe, is like the TIM study has fourth grades, third and fourth graders in the original study tested, and they did better, and so people assumed that we didn't have a problem there. But I think what the Common Core is doing is trying to get, as they begin to learn and get exposed to number, is to really understand in a deeper way number and how it works. And so I think, yes, it is changing in the early grades. And hopefully when you develop that deeper understanding of number and how it works, like that number line problem, that then begins to, and the other one that's really important is equivalence of fractions. I mean, this is something in the United States that we just have enormous trouble with. And it's because they, when they have to add fractions and they don't have a common denominator. Well, if you understand what equivalent fractions are, that 2/4 is the same as 3/6 is the same as a half, that's the basis for all of those manipulations. But if that's not clear, then they get to this point where they get this formula that they're supposed to use, and then they just have to memorize it because they really don't have the sense of what they're trying to do. If they have a better sense of how those numbers can be equivalent, even though they appear to be different, then I think those algorithms, it also sort of addresses the earlier question, because those algorithms then at that point use them, because you don't have to keep doing this in a long version of thinking it through. Once you get to a certain level of understanding, then it's quite acceptable to use these various tricks, algorithms, skills, we call them. And I think that in the early grades is where that foundation of understanding is very important.
Very good. Well, several comments I'm seeing relate to rigor and this focus on thinking about the why of our thinking and our mathematical thinking processes. And several folks are relating that to the first question. So you have touched on this a little bit in some of the previous slides related to rigor, but I didn't know if you had any more thought on those types of comments.
Well, rigor sort of naturally occurs in mathematics if you if you are recognizing the logical structure of mathematics and then the issue of coherence. In other words, as you go through mathematics, in some sense, you're always progressing because of its hierarchical nature. So you learn first about certain numbers, then you add some other numbers into that, like fractions, and then as you go up, you start adding negative numbers, and you're building an understanding of the rational number system. And in a certain sense, the rigor occurs naturally. And in the same way that it progresses across the grades, you move from basic number and shape, and then you move into what's kind of other kinds of representations of relationships among number, like proportions, ratios, and then you move into algebra, because now you're formalizing a lot of that, and that's the segue into still more advanced mathematics. So that rigor is sort of natural. And I think that's the thing we seemed, before the Common Core and many state standards to be fighting, because it was like we kept doing the same thing year after year after year after year, which was dreadfully boring for the kids and basically led to nowhere. And that's why one of the findings in that original study was by 8th grade, most of our kids were still doing arithmetic. And the rest of the world's kids in 7th and 8th grade were doing algebra and geometry. And so that's what's meant by rigor, is that there is a natural sort of evolution to the complexity of the mathematics if you let mathematics proceed and the instruction follows that sort of internal structure.
That's very helpful, Bill. Moving down into our question on literacy, one of the things that I see there that folks are bringing up relates to technology and the use of technology in math instruction and how that's become critical. Would you talk to us a little bit about your experience there?
Well, I am somewhat of a skeptic on depends on what you mean by the technology and how much of it and things of that sort. I think we tend to, in the U.S. too often, look for the simple solutions to doing things, and we think there is, if we look hard enough, we can find the way to make it all quite easy and simple and just it'll all fall into place. And I think sometimes that technology, some of these gimmicks that people put out and say that it's aligned with the Common Core, it'll help do this, I'm skeptical of a lot of that. Not to say that there aren't some uses of technology and some online programs which actually do a decent job of taking kids. But I think those are few and far between, and I would simply caution parents, teachers to be cautious of those and make sure that the technology sits in support of developing this conceptual understanding and doesn't just become a gimmick, where you're shooting things at a chicken that has a number on it that somehow represents something, and it becomes more the game and not so much the understanding. In a field far from not so far, but far from mathematics, where as an example I like to use is this fellow as a geneticist developed this program to teach science in elementary school, and it was doing different kinds of things with the genetic makeup and that. And what he said when he was reporting the results of that work, he said, well, gee, I can tell you two things. First of all, the kids learned how to do this, play with this game really, really well. They caught on very quickly, and they could do all the stuff with it. But the second thing was, I don't think they ever learned any real genetics in the process. It was divorced enough from what they were doing in the classroom that it was a game, and they mastered the game, but they never understood genetics in any serious way. That's my worry with a lot of technology things. But
that's a good segue to my next comment. One of the other themes I'm seeing in some of the responses relate to the notion of problem solving and application to real world situations. As we know, the Common Core really pushes for those standards to really encourage those skills in students. How do we maintain the fidelity of the standards and still promote this problem solving and real world application? How have you seen that done well in classroom?
Well, I go back to the PISA results I shared with you earlier. I think what I learned from that and from other experiences is that there is a place for the application to real world problems. It does make a difference. There actually is a pretty sizable effect of doing that on the performance on the literacy test, but it has to be balanced with the more formal aspects of mathematics, the part we've been talking about. So it's in that balance between the two, and I think that's an area that's open for further research, which might contribute further insights as to what that balance should look like. But clearly, too much of one, either one, leads to an imbalance that probably hurts the ultimate literacy of the students. So I think that's an important question that I don't know we really know the answer to. But I do actually believe from the data that we need to make sure that as we do this, we do give children opportunities to deal with applied problems. And what I really would encourage on this point is, this is where the math practices come in, because it's in that context that how you think about that, what you might model, what you do to solve a problem. You look for structure, you look for these kinds of things. That's where you can really teach children to engage in the way of thinking mathematically about problems. And it's really important that kids have that experience. But I think the caution is that this has to be balanced, because it's very clear also from the data that it's really important that the kids do have the strong background in the more formal aspects of mathematics, because therein, in every single country we studied, that was statistically significantly related to performance on the literacy test. So don't be led astray to think that math instruction could be solely based on just doing problems. It needs to be balanced with that. The second thing I would suggest, and this is just a personal note, just give me that as a personal comment, not research-based, but I have a degree in mathematics, PhD in statistics, but I can tell you, I absolutely hated, and to this day still hate, what passed for in many math textbooks applied problems. They're just stupid, like two trains heading at each other, things of that sort, which I often said to myself, I don't care. Why would I ever care to figure this out? And so the problems have to be real, that really maybe are something that's realistic to them, that they've encountered, they might encounter. These kind of traditional word problems are really pretty fundamentally, well, actually, I'll say what I think. They're fundamentally stupid, and why would a kid want to do them?
So, Bill, to that end, do you have any recommendations or thoughts about how this is being done better in this new era of Common Core? Are we finding curriculum writers or even textbook publishers to be responding in a more positive way, given your comments?
Well, I'll tell you more about that when we pick back up on the other slides and the data. But just as a prelude, I think there is a movement in that direction. I think we have a way to go yet, but I think people are taking that more seriously. And I think it's these are very different kinds of things we're asking of textbook writers and test writers to develop, and I think it will just take a little bit of time till we get to the point where we really need to be. But I do think there is improvement.
I think having the conversation is the first start, and calling attention to the needs and the differences that we see. So one question I want to get to that's in the parking lot before we move right along. Nicole raises a point that I know many educators struggle with in mathematics and in other subjects as well, but it's a little bit up if you want to scroll up in the parking lot. Nicole states that her struggle is that when students do not have the basic math skills necessary to have success with grade level math concepts. She teaches 6th grade, and while teaching ratios and proportions, she had a student who could not tell what 2 times 5 equals. And though she has strategies to address this, she's wondering, how is this student supposed to succeed if he's completely lacking the basics? So this is a struggle I hear a lot, and I'm sure you hear as well. How do we ensure that those basic skills, like you were just talking about, that is a necessary precursor to applying problem solving and applying to real world problems? So how do we ensure that this is happening, especially when students are coming in lacking skills at the grade level?
Well, my answer to you, Nicole, is if I knew the answer to that question, I could probably be Secretary of Education or maybe even King. That's really the heart of the problem in the current implementation stage that we're in, is we have these gaps in knowledge that are created by, previous times. I think you said 6th grade. They've been in school for already 5 or 6 years. And so what's happened there is going to impact what happens in your class. I don't know that there's a really good answer for you on that. I can tell you what some districts do, which I think it makes the most sense to me of all the attempts to solve this that I've seen, is they hold the kids to the basic progression for that grade, like in 6th grade, cover the 6th grade standards in the Common Core. But they have their daily scheduled so that there's an extra period in the day in which the kids that are behind in that can go to a class which runs and as kind of like the building up helping to build up the background and deal with those things that have been forgotten or never learned, so that they actually stay with the flow of the regular class, but they are then those that have this problem required to go into a separate session in which the teacher builds up that background and tries to fill up those holes. Otherwise, to leave them behind is sort of not what one wants to accomplish through the Common Core. But short of that, you an individual teacher on your own, I'm sure everything you're doing to try and build up her background is probably the best you can do. There's just no real good answer to that question, unfortunately.
Well, let's move ourselves along, Bill. I'm interested to hear a little bit more about the research base, as I'm sure our participants are. And you all can keep the comments and questions coming in the parking lot. We'll be sure to address those as we go along. And we'll get into this next section now.
Okay, well, we're going to talk a little bit more about the research base behind the Common Core state standards in math. And I want to address several issues that come up in this context. These are really could be labeled as the things that we've learned from the research that we've done that seem to serve as an impediment to the successful implementation of the Common Core. This is all based on real data where we've been doing over the last few years, looking at teachers as they're trying to implement the Common Core. And here's a display that the sets of columns across this are grades 1 to 8. And in each grade, in each of those columns, if I could call them that, there are two rectangles. And one of them is on the left is what the teachers, an average of teachers teaching at that grade level, how they allocate their instructional time over that year. The second of the two within that each column is labeled with an E, and that's what a set of experts that we gathered together who looked at the mathematics. These were people in mathematics as well as in math education as well as teachers. And they looked at and said, well, here's how much time you would need to do this topic, and that topic, coming and directly referring to the Common Core. One of the problems with the Common Core is that at this point, at least, there is no clear definition or set of numbers that help you understand the difference between one standard and another standard, or one cluster and another cluster. And for many teachers, it's difficult for them to know that they don't perhaps have enough math background to know that one of those might be 1 week, one of them might be 1 day, and another one might be 2 weeks. And so what we did there was to see how that lines up, how teachers allocate their instructional time. This is a big issue. There's a whole set of research to suggest that the most important resource in a school is the teacher's time and how that time is allocated both across different subject matters, which is often set, but especially within a subject matter, and given what has to be covered in a given year, taking as defined by the Common Core, for example, is to figure out how to allocate that time over that year so as to not run out of time at the end of the year when you've left, half the standards uncovered or some percentage of them not covered. So this display just illustrates, I think, a real fundamental problem. And I call your attention to 3rd, 4th, and 5th grade. It's easy because the blue is easily seen. The blue represents fractions. And all of you that are teachers on there, and I see many of you are, you basically know that around 3rd, 4th, and fifth grade, that's the big item. That's really the one that has to be understood. I mean, quite simply, if you don't understand fractions and working with them, then you have no chance at algebra in 7th and 8th grade or in high school. So this is critical. And now look at the difference between the blue and those two in 3rd grade. The experts are suggesting more than half, again, as much as what the teachers were allocating to the coverage of that. Perhaps this is why when we look at the results on any of these international or other tests, this is an area where, in fact, we do particularly poorly as a nation. Our children have a great deal of trouble with fractions. Now you move to 4th grade, and you can still see that there's not quite as big, but there's a gap again between what the experts say and what the teachers actually on average. And this is not one or two teachers. This is a sample of 20 or 30 teachers that we've averaged over. So it represents a sizable number of teachers. And in 5th grade, you still have a difference, but it's not as great. It's narrowing. But now, by the time you're in 5th grade or 6th grade, if you're way behind from 3rd grade in terms of enough time being spent on this to fully understand, you're going to have a lot of more trouble than as you go, well, in 5th grade and in 6th, 7th, and 8th. And so this kind of thing raises a very serious question of how we help teachers to understand how to allocate their time across these different topics that are called for in the Common Core standards. So that's the first point, that this is really a critical issue for teachers and it's a struggle, and it's a threat to the proper implementation of these standards. Another one is, how well prepared are teachers to teach these different topics? The new Common Core standards are more demanding. They're more rigorous. They're more mathematical. The level of knowledge required is at a higher level than what was previously the case. So we did this survey over, this is actually over hundreds of teachers at each of these different grade levels. And what you see here is 4th and 5th grade teachers. Their indication, this is their self-report. Nobody's making a judgment about these teachers. How well prepared do they feel they are to teach? And here's the percent who feel they are very well prepared to teach these different topics. You can see it in whole numbers is the largest percentage, that in common fractions, but there's still about 25% of teachers that say they're not very well prepared. Now notice the wording on this question. This is not to blame teachers. It has to do with how well prepared they were. The question actually asks how well academically are you prepared to teach these. This may well be a condemnation on the colleges, the universities, the colleges of education, who simply don't demand more of a level of preparation in the actual mathematics. And that then might be more the place where this problem lies. But look at 3D geometry or slope and trigonometry. You might say, well, 4th and 5th grade teachers don't teach those things. But if they have no understanding of some of these things, how well then are they prepared to teach some of the stuff they do teach in 4th and 5th grade? This slide asks the same kind of question of middle school teachers. And you can see, since now in the Common Core, coordinates, lines, and logarithmic equations, linear equations, these are all things that are in there in some form. And look at the percentages who are prepared to teach this. Linear equations, look at that one. That's a fundamental concept now in 7th and 8th grade. And about half the teachers say they're not really their own judgment, they're not very well prepared to teach this. I commend the teachers for being honest in this survey to give us what I think may still be inflated. That is, it might be worse than these numbers do suggest because of self-reporting. But these are really fairly honest claims that they don't have the background. Nobody required this of them when they were in school taking these courses, and their program did not actually make them, request of them to take these courses. I'll interject here, we did an international study of 18 countries where we asked how the teachers were prepared, and we actually tested the teachers in their last year of preparation to be teachers. The sample in the United States included some 83 public-private universities randomly drawn to represent the United States as a whole. And we inquired of them their preparation in several areas. I want to focus, given what I've just shown you, on the math side. And we find that most of these teachers, well, let me back up. We asked the teachers of the top performing programs in the world. There were about 40 of those that really, their students were of the best prepared on multiple counts of their knowledge to teach mathematics and their knowledge of mathematics itself. And when you look at that, we said, all right, what's in common across those programs? And we got what we could call an international standard of math preparation. For example, for middle school teachers, it was like six math courses and several two math ed courses and one general education course. And what we find is that when we apply that metric to the U.S. sample, only about a third of our teachers met that metric, whereas teachers in a country like Russia and Taiwan, Singapore, 90-some% of their teachers met this international benchmark. So what we see from that study is that one of the issues is our programs in this country do not require the same level of mathematics preparation. And that really sets up an issue of who's entering in, the level of knowledge of the teachers as they finish their preparation programs. I think, and I lay this squarely on the universities and colleges of education and the requirements and what they expect students to take while they're in school. And I think there's an area that should be thought. It's well beyond what you as teachers can do, but it certainly is a policy level issue that jumps to the foreground. So I'll kick it back to you again, Elizabeth.
Sure thing. Before we jump into this question, I want to respond to one of the questions over in the parking lot. I think Edward was asking if we can provide a more clear version of the graph that was on slide 23, and we're going to work on that. We're going to put that in the resources to download box in just a few moments for you. And it seems like that the comments I'm seeing in the parking lot really struck a chord, that slide struck a chord in this section on where teachers are allocating their time. So it's a good segue into our question, and we want to find out from everyone in the audience, how prepared are you or others that you work with, other mathematics teachers, for teaching the Common Core? So Bill just shared with us some of the data and some of the experience he's had with teachers, but we're interested in finding out from the field, from all of you. So we'll put up another poll, and we'll take a few minutes to respond to this question and have some discussion about preparation. And while we do that, I know one of the questions that we received before today's session, and one that I'm seeing some comments on, and something you just spoke about in the last comment, Bill, was related to pre-service and teacher preparation. And I think it was helpful that you made that comment that we need to strengthen the education schools in the approach there, but also that it comes down to a policy level. A lot of times in many of our webinars, we have folks in higher ed, and their questions relate to how can I do my job better to better prepare teachers for the field. So I don't know if you have any more thoughts on that while we're waiting for folks to respond to our question.
Actually, I'll give you one more piece of information which will only further depress you if you haven't already gotten there, and that is that in that same study we took and ranked the colleges and universities in the United States as to the scores, the average score of their teachers that were graduating that year, their future teachers, on a test of their mathematics knowledge and a test of their pedagogical knowledge related to the teaching of mathematics. And we looked at and found that and divided that distribution into 4 parts. And the bottom quartile, the bottom 25%, essentially had scores that were comparable to not Russia, Singapore, Poland, Taiwan, any of those, Germany, but to Botswana, a developing country in Africa. And that really speaks really strikingly to that we actually are putting out teachers whose level of knowledge is much more than what what's found in 2 or 3 of the developing countries that were part of that study. And here's the scary part of it. That 25% of the institutions, because of the size of the graduating classes, produced over half of the future middle school teachers in the United States in that year. So in other words, there's a real issue here with respect to teacher preparation, which really raises the policy question with respect to states who certify different institutions to grant degrees that allow for teacher certification, and what they require in their own certification. There's a real policy issue there that nobody is kind of willing. I mean, these results have been out for a while, but nobody seems willing to really take on the implication of those results and think about how things should be done differently.
It seems like you're raising a lot of questions today, Bill, that we as educators need to press forward with. There's still a lot of solutions that we need to find. So you're giving us a lot of great food for thought and some actions that can be taken on some of these points. So let's get back to the question in the middle of the screen, thinking about preparation and how prepared are our folks in the audience feeling for teaching mathematics in this Common Core era. And it looks like it really runs the range, but people who maybe have a stronger math background and have a degree in mathematics might feel more comfortable and prepared. And I see a couple elementary folks who feel prepared, but there's kind of a range there. I don't know if you want to take a look at a couple of those comments and see if there's anything that jumps out at you.
Yeah, actually, I was just reading them. I think it's interesting that several of them seem to be suggesting that the secondary teachers don't have the background or are not prepared to teach. And I'm curious, for people that are saying that, I would have expected that the secondary teachers would have, because in many places to teach at the secondary level you actually have to have a degree in mathematics. So I was wondering if when those comments are being suggested, it has more to do with their pedagogical aspect of preparation, that is, that whether they know how to teach students, or whether it really is that they don't seem to know the mathematics that's required. That's one thing that jumped out at me kind of quickly.
That's a great point, and I think that's the bridge we need to make between the schools of education and the how of teaching mathematics, coupled with the concepts and the skills of mathematics. So clearly something we can continue to improve as a field.
The other thing that I noticed from some of these comments, just a general thought, is I think we have to some extent, and I want to say this carefully because I don't want to be misunderstood. I think that some of the knowledge we're talking about is not going to be found in, how do I want to say this? It's difficult to say it without sounding critical. I think there are a lot of self-help books and so forth that are out there for teachers and that. I doubt whether the level of the mathematics and the depth to which it's being presented and needs to be presented, because if the teachers themselves are going to teach for the conceptual understanding, they have to have a deep conceptual understanding, not just of that set of topics they're teaching at that particular grade, but well beyond that, that grade that they're teaching. They do have to have a deeper conceptual understanding so that they can recognize the misconceptions, so they can recognize when the student is asking a question that on the surface it may appear to be silly, but when you actually understand it at a deeper level, it's really an important question. And I just don't know how much of that can be remedied, but I think so much more of it has to be done as a part of the actual preparation of the teachers before they get into the classroom, so they have that deeper background on which they can then build. So I just, there's a concern that I have. Some of my mathematician friends suggest that the amount of hours it would take to bring many teachers up to the level to be able to teach what's actually desired at the Common Core would require just a huge amount of professional development. So I don't want to be sounding so negative that I don't think that any of this helps. I just think it's something we need to face. It's really a teacher preparation issue that I think we can't keep putting our thumb in the dam and expect it to hold the water back. I mean, I think we have to fix the source of the problem, which is our colleges and universities. And the real issue there is in many of the universities and schools, teacher education is one of the cash cows. It brings in a lot of money and it doesn't cost very much because they don't need labs, they don't need chemical things and what the sciences require. And so people are not willing to look at that more carefully. And I just think it's quite irresponsible on the part of our universities and colleges with respect to the issue of teacher preparation.
That's an important angle on this conversation, and one I want to keep in the forefront of everyone's mind. Another one, in taking it in a slightly different direction, is a question that Tiffany has in the parking lot, and one that we also received, and you and I, Bill, discussed this before today's webinar, this role of parents, and how can we as educators better communicate with parents and explain this shift to the Common Core. As many of us probably know and see, as parents and as educators, there are a lot of misconceptions out there about the Common Core, particularly in math. And so how do we make sure that parents have the right information in their hands and understand this shift that educators are facing?
Yeah, that's a really difficult problem that unfortunately falls to the teachers. I really think, to be honest with you, what I recommended a long time ago was that, and I have a friend who is a media person. He's a marketing researcher, so he's lived his life in convincing people to, or trying to understand what people want from a product or whatever. And he came to the same conclusion that I did, which is we really need, I think, in this country, much more of a national effort that really helps people, parents, to understand what this is all about. Now, it could be done at the state level or whatever, but I just think there has to be more attention put to the problem of helping people to understand, not to argue about whether it's good or bad, but to understand the nature of it, and for the parents to get a better understanding of why what is happening here is happening, why it's good, well, how it's different. And we've never really expended any effort, money and other kind of expertise to deal with this. And so it falls on the teachers. And the parents are upset because what they see when you help children move to conceptual understanding, they see it as goofy math, because they're doing something where if you just did the old 77 times 3 and 7 times 3 is 21, carry the 2, and you just follow through that algorithm, you could get the answer. And here these kids are writing 70, I can't even remember what they just said, but anyway, 70 plus 3 times 3, then they say, why would you do that? That's just silly. Well, no, it's not. Then you understand why that algorithm works. So if you ever were to sort of forget it for a moment, you'd remember, well, 73 is 70 plus 3. Therefore, and it even actually helps you to estimate numbers, because 70 times whatever I said, 3, that's easy, and you can just get a general sense of how big the number would be. And so parents need to understand why that's happening, because I think they think they're being taught stupid algorithms that they don't think are smart. Why don't you just use the old standard algorithms I learned when I was in school? Well, nobody's changing that. The Common Core still wants you to memorize your multiplication tables. It still wants you to understand these basic algorithms that we've learned for multiplying, subtracting, we have to carry, all of these things. That is the heart of a big part of the Common Core. But the other part is, okay, understand why that works the way that that works, so that when you encounter other problems where it's important for you to recognize the place value, you can actually understand the number system well enough to recognize that, you have a chance then for the kids to really be able to go beyond just the algorithm. They actually have some understanding that may well help them to solve a problem of a more complex and very applied nature. When they start thinking about, well, I'm doing this room, but then this part comes in. Well, it's really 7. Then there's the 3-foot wide space here for that. You have a better way of thinking about a lot of problems if you actually understand the number system. And understanding the number system means not just counting. It doesn't mean just multiplying. It means that number line. It means the understanding of what those numbers represent and what they can do with them and what it means when you do with them what you do with them.
I would also call your attention to the parking lot, folks, that there's some great resources being shared on this topic of engaging parents, some real-life examples there. And I would also mention and plug one of our previous sessions just a few weeks ago, actually. We had a session on parent engagement. And if you refer back to the Rel Mid-Atlantic site, you can see that archived webinar. And although it does not speak directly to the mathematics classes and instruction, it has a lot of great strategies and thinking about how to engage parents in the education of their children. So that might be helpful for some of you folks that are looking for ideas there. Let's move ourselves along, Bill. I don't know you want to get into talking. Go ahead.
I'll just make one quick comment and move along. I was just going to say that I think that's really one of it. Those of you that are teachers probably already know this. You don't need me to say this. But basically, I think that a lot of the problems that I encounter here, especially in East Lansing, just as a member of the community, are these images that people have about this Common Core, the parents. And they're so ill-founded and incorrect and so influenced by the talk show hosts and things of that sort. And so that's one aspect. But the other aspect of it is, I think that and this may be what you're talking about, some systems which help I know one of the series that I've seen actually sent, with my daughters, sent home a sheet that sort of explained the lessons and what the things were for the next unit and something like that. And that's, you probably have already thought about, but that's just something I remember that it would be helpful to parents that don't have a lot of math background to sort of see what's going on and why they're doing what they're doing. I think if parents had a better understanding that in the end they were going to be doing their math pretty much like they themselves did it, but the route toward that end was a little bit different, and the reason why that route was different, that might go a long way towards reducing some of the parent flap that's being directed back at teachers. So let me go on, because earlier on somebody asked, I guess it was you, Elizabeth, mentioned something about the instructional materials. And that's the next point I wanted to make, is that this is a real problem for teachers, that what is out there in terms of textbooks and instructional materials, and even the stuff that's coming out fairly recently, is a real serious problem. This is an analysis we did of a very serious piece of research where we had math graduate students analyzing these books, not making judgments about the books, but actually going through and coding these books lesson by lesson. And here are some of the findings. We found that these K-8 textbooks miss about a quarter of the required math topics as required by the Common Core. In other words, if for a coherence to occur, all the standards at a given grade level should be covered, because it's progressive, it's cumulative. And so if you skip something, then the next grade, the teacher has the problem, somebody was alluding to this earlier, has the problem of trying, what do you do with somebody if the whole class, for example, has not even had that? And in our analysis, we did not find one single series in which it covered actually all of the on-grade standards called for in the Common Core. So that's a pretty serious statement, that really among these 34 that we analyzed, we could not find one that totally covered everything it should at the grade level at which it should be covered. The next slide shows that that half of those classroom textbooks actually focus on the grade standards. In other words, there's two issues here. One is they don't cover all of what they should cover, and this one says that they cover a lot of what they shouldn't be covering. In other words, they're addressing standards and things from other grades in that particular grade. Well, the standards have been put together with a notion and an idea towards focusing on coherence and making sure that the progression reflects that coherence. So when you have this occurring, that the textbooks, now you might say, well, why is that important? Well, because teachers often, many of the teachers with lesser background in math, use the textbook. They should. Everybody in the rest of the world's schools use textbooks. The big difference is their textbooks line up quite well with their standards. Here, that's the problem. So if you follow the textbook, about half your time you're going to be off standards, off what you should be covering at that grade level. And so I think those two are pretty strong indictments of the textbooks that we have. Now, there is a piece of good news, and I think you asked me this earlier, Elizabeth. Some of the newer ones are better. They actually cover a higher percentage of what they should, and they also spend less time on the off-grade material. So that's good, but we still don't have a book that covers all the standards that should be covered at a given grade. No series does that. So what we're leaving teachers with is a tough job of teaching a more advanced to a more advanced set of standards without curricular materials that are particularly supportive of that approach. So taking your books, and of course we're just coming out of that deep recession in which states drew back their expenditures, so not a lot of new books are being bought right now, and yet we have to have the teachers trying to teach to these standards. So that's a real serious problem. And just to give you, just quickly, you don't have to focus on these numbers, but this just gives you a quantitative sense of what I'm talking about. There are 200 for all grades in this. This is a K to 5 book. There are 231 standards that should be covered over all those grades, over all the whole series as a whole. And the next line shows you that only 166 of the on-grade standards were covered. So there's your gap. They only cover about 72% of what they should. And then you ask the other question, well, how many of the standards that were covered, how many were on grade? Well, only about 29%. You can see there are 132 standards that were below that were being covered off the grade they should be, some above it. So this just shows you that, here's just broken down by an individual 2nd and a 5th grade book, and you can see that, there's just, take that 5th grade book, there are 40 standards that should be covered at 5th grade. The book only covers, at 5th grade, only covers 25 of those standards. And where did the rest of the standards come from that are being covered? There are 30 from below grade levels and 52 from above where they should be. All of this means that these materials are not very supportive of teachers' implementation of the Common Core standards. And here are just two illustrations of coherence in sort of a graphic way. The gray area you see is what should be being done. That represents the Common Core standards. The dots represent where that particular grades 1 to 5 standard, 1 to 5 textbook series, what it covers. And you can see lots of dots outside of the gray area, meaning this book covers lots of materials, especially at 3rd, 4th, and 5th grade, that are not appropriate to that grade level. The color of the code of the dot has simply to do with the amount of time that's allocated by the textbook to that, which is not that important for this discussion. But here's a more recent book, and you can see that they're much better. There's much less stuff that's off grade, and there's an improvement. So things are getting better. I don't know how many of you saw the Ed Reports. They put out an evaluation of many of these same series that we just did, and came to essentially virtually the same decision as to the quality of what was out there and what was available. There are some new books, more recent than what we've done, and I'm not speaking to those, but I can tell you this as was the case as of just about a year ago. So I bring me back to that slide I showed you a while ago. I've added a third column, a third element to the big columns, the 8 columns, and I point your attention back to grades 3, 4, and 5, the blue. Now you have the teachers is the furthest left within the set of 3 in a column. The one in the middle is the experts, and the one on the far right is the textbook. And I made comment about how the experts suggest so much more than what the teachers do. Now compare what the teachers do to what the book is, and there you find the agreement. So what teachers are doing in terms of the amount of time they allocate is what essentially their books essentially are either dictating or create by their use. So what we have is that teachers use those textbooks, and that helps to define that time. And that, of course, then is in opposition to what the experts believe should be being done. And you can see, I mean, that's a big gap. Twice as much at the 3rd grade when you're first introducing the notion of a fraction, when you're building it as a number as opposed to a part of a pie. And so you've got that being cut in half in terms of what the experts feel is the amount of time that should be put to that particular topic. So this then suggests the further part of the problem, which is the textbooks themselves. This misalignment, I've said much of this along the way, the huge variation really contributes to this inequality I was talking about previously. If you have such a large variation in what standards are covered and how much time is being allocated in the textbooks toward the coverage of those standards, this just creates further inequality in terms of mathematics coverage. And we know from that PISA study I shared with you that actually is very much related to performance. Excuse me. Now,
Bill, I'll jump in for a minute to let you catch your breath and
okay.
get a drink of water.
I've got it back if you want. We wrote a book called Inequality for All, in which a lot of data is laid out showing how this is true in the United States. But now, I take you back to that first slide. Without going into the detail of how this is done, we broke this down into 2 parts. That overall slide I showed you way back at the beginning. This is the part that's due within school, the SES inequality that arises within a school. And look at the United States. You can see that the added on part from the schooling is very large. It's among the largest in the whole of the 34 countries. So we have a huge effect that's going on. What that translates is in the U.S. a substantial proportion of the within school SES inequality is due to this schooling effect, this indirect relationship involving who gets to study what. This is why the Common Core becomes so central. Even within a school, what this is saying, what has been the traditional case is different classes get different amounts of coverage in different content areas in mathematics, and that is related to social class. And I know this is true in the schools in the communities that around here. I know this is very much the case because we've done research in that. So you end up with this kind of a problem, and this is why the Common Core is so critical to dealing with the second aspect of what we want to improve, not only excellence but equity as well. By contrast, just because I thought you'd be interested, this is not a big issue in the United States, is the SES effects between school. So if you look at the United States, there's not a big between school component. That is not where most of the inequality resides in the United States. By contrast, it's almost totally that in Korea and the Netherlands, where different kids are sent to entirely different schools with entirely different curricular opportunities, which is then related, probably not by design, but by consequence, to the social class. And so you have this huge amount of inequality being contributed through the schooling. So this, I think, really raises a question that we need to confront. Most of the emphasis in the United States right now on improving schooling is failing schools. I know that's true in Michigan. I know it's true in other states. And nationally, the rhetoric is around failing schools. Well, the fact that this slide shows a large component within, and this slide shows a smaller component between, that may not be the best strategy. Put simply, I think we have to work with the kind of tracking and student choice, the whole set of issues that lead to different students being exposed to different content, starting somewhere in the middle school at least, if not earlier, is what is producing this large within-school SES component in terms of performance on the PISA test. So I give it back to you again, Elizabeth.
Sure. Well, you know, we're coming up about 30 minutes left in our time together, so we want to touch on a few other questions for our participants. And just pulling on this conversation that we've been having about the textbooks and the different type of instructional materials, and I see some of that going on in the parking lot, we want to open it up to you all and find out what type of curriculum or textbooks, or even if there's other instructional materials you might be using in your mathematics classroom, and talk to us about how effective you perceive them to be. So we'll put up that poll and get you thinking about that question. And while we do that, Bill, I had a question that one of the participants had asked in advance of today's webinar, and this might be a little more than you want to take and tackle right now, but I think it's a valid question, and it probably takes us in a direction to address some of the other roles of non-classroom-based educators. So the person asked, what would an effective math lesson look like from an observer standpoint? And I want to maybe even frame that a little bit more broadly and say, what would a person, a principal, an instructional specialist, an instructional coach, what types of things should those folks be looking for if they go into a math classroom? In a lot of cases, those folks may not have the math background that the math teacher has, the content expertise. So how do we guide those people in those roles to go into classrooms with an eye toward the right thing?
That's really an excellent issue. Let me just preface it by saying this, that there is some research by Dick Elmore at Harvard that, and he actually, in looking at some of the data we had one time, made this comment which was striking to me, is that basically the most important, that what a principal, you ask about a principal going in, for example, what a principal is, the most important thing that they can manage as a mid-level manager in that corporate sense is the allocation that teachers have of the time that they do. So in addition to going in, I think teachers, principals and superintendents should be monitoring the allocation of time in mathematics to see how consistent or inconsistent it is with the set of standards that should be being dealt with. And so I think that's a real important issue for people to do. Now, in terms of going into the classroom, it's hard to sort of get a general pattern for this, but what I would say is that, first of all, you would find the kids actively engaged in this process, not just by raising their hand to answer what 6 times 2 is, but to what you would see is the teacher putting or posing a problem, a practical problem, a mathematical problem, and you would see students engaging in a dialogue, not just teacher to student, then teacher to some other student, but that actually you would see more of this interchange of ideas and so forth that actually go around not so immediately being concerned with the answer, but thinking about ways to attack that problem with the mathematics they know. So you'd see, this comes back to those math practices. Um, if you see what that really is meant by those 8 math practices, if you see that being employed, not in terms of, oh, here's this math practice, but it just manifests itself in terms of the flow of the instruction, that's what you would want to see. That's what would make the lesson look different. It wouldn't be a short 10-minute introduction to some new topic and then all the kids go and start doing their homework as seat work before the bell rings. You'd see much more of you'd see the whole period being utilized, and it would be involved in this kind of exploration of the issues surrounding what it is they're learning and looking at problems even that might not be solved in the same day, that the teacher poses a problem and the students go off and it comes back the next day, all right, we never solved this, how do we do this? It's more that kind of engagement with the mathematics itself, not as just do this problem, okay, well, who got what answer, but it actually involves understanding, thinking, exploring problems of mathematical sorts.
I think that that's very helpful for folks, both from an observer support standpoint as well as from an educator standpoint, to know, how they should be structuring their instruction to deliver the best quality instruction. Taking us back, we're going to quickly just discuss some of what I see here in the responses. I see a list of several different types of textbooks and resources that folks are using. Some of the more traditional textbooks and some of our more traditional textbook providers are there, but also looking at some of this more open source materials. In some places, folks are piecing together materials that will support the standards. And you've talked a bit about this already, but I don't know if you have other thoughts based on what you see here from the participants.
No, actually, that an open source, one that I think is quite good is the one out of New York. That we have looked at, and I think that's really lines up quite well with the Common Core standards. I think it's called Engage New York. I would say that what's being discussed here, and a lot of the books that people are talking about, Envision Math, Go Math, we've actually analyzed all of those. They're part of the series the series that we have analyzed. So I don't know if you want to move to that, Elizabeth, but basically one of the things that would help in some ways is to look at the Navigator, which is coming up. Should I go there now, or what do you?
Sure. Yeah, that's a great segue to the next section.
Okay. Okay. Along that way, these are just some thoughts that, like I said, principal leadership is critical. I think this teacher time issue is a huge issue, and I think that there is need for leadership there so that the classes don't get so far off. I mean, if you have one class going at this pace and another class at a slower pace, then the one class is going to end up without covering some of the standards. And when this Common Core standards are so coherently put together, you should cover all the standards at that grade level. That has to be the requirement. Otherwise, children are going to have more difficulty when they go to the next grade, and the expectation is that they do know these things. We talked about the teacher preparation and the importance of that. So here's, I think, I would just make a comment on a couple of these. Tracking is probably one of the most nefarious, awful things that we've ever foisted on the American educational system, this notion that somehow we should track children into different groups and then teach them different mathematics. We've done a lot of research on this, and basically what it shows is the more advanced kids get a small kick at the cost of the kids who need schooling the most. And in fact, when you look internationally, the kids that are tracked around the middle grades don't actually end up much better by international comparison. So it's just a game we've played by listening too much to parents who think their children are actually reflect the Lake Wobegon where they're all above average and therefore none of them can be in an ordinary math class. I think that's such an awful thing and is totally antithetical to the Common Core. So anybody that says they're doing the Common Core and have two versions of algebra at a given grade level are simply not really in the spirit of what the Common Core suggests. Hiring new teachers, given what I just described to you, if I were a principal or a superintendent and had to make these decisions, I'd want, and I suspect a lot do, I'd want to know what math course, if they're a math teacher or they're going to teach math, I'd want to know what math background they've had. For elementary teachers, it's a little more difficult to determine that, but surely for middle school, and it would be obvious for high school, but especially for middle school, I would really carefully check their content preparation. The last point on here I think is really critical. The standards should drive the instruction, not the textbook or the instructional materials that the teacher is using. The standards should drive the instruction. The textbook is a tool to do this. It is not the definition it should not be the difference of the definition of the curriculum. And this, sorry, I had trouble getting it to flip to the next one. These are fairly obvious statements, I think, looking at misconceptions. Being able to recognize what those misconceptions are is so important. As we watch some of these videos, teachers sometimes just don't see how the student came to the answer they did. Yet the student used some algorithm of some sort to come to that answer, unless it was just an arithmetic mistake. And so you really want to be careful and watch for this. And again, provide the same opportunities for students so that kids of a lower social class are not being given different. These are all, I think, fairly straightforward, very important kinds of things we've learned. Some of this we learned way back in the original TIM study with Jim Stigler at the UCLA when he did the video study of Germany, Japan, and the United States, and came up with some of these standard practices which seem to make such an important difference. Now I want to come to this thing that is called the Navigator. This may sound like a commercial, but it's not, because it's something we developed with grant money. It is free and available to any teacher that wishes to do it, but it is an attempt to address the issues that we were talking about with respect to the textbooks. That we have these textbooks that don't line up particularly well. And so those books that we analyzed, what we did is we coded them completely as to the standards that were being dealt with at each of the lessons within the textbook. And what we did is to build a web app that you can access by any device, computer, a laptop, an iPad, any of those things. Teachers can then go on, say that, for example, I'm teaching third grade. My book that I'm using is Connected Mathematics, the 2-year-ago version. You can get on that system. You can say then, I want to teach this standard at third grade. The system will then tell you where in that book and in that series writ large there is any material toward addressing that particular standard. It may also say to you, there is nothing in your book or your series to which that particular grade level book is a part of, and therefore then sends you to a site to give you an alternative way to deal with that standard, given that there are no instructional materials in the book that you're using. This we did with all 34 of these books that we've analyzed. And then not only can you do it that way, which allows to the standards to drive the instruction, not the book itself, because you could say, I want to teach this standard first, this standard, and then the system will tell you where to find all the sources in your book that you might find this. And I think a lot of you know that the way these textbooks have been organized is you might have something on a given standard on page 10, it might be again reappears on page 30, it could reappear on page 200. This system tells you and shows you all the places where that standard is addressed in your material. The other way you could do it is just look at your book and pull up a lesson, and what it tells you is which standards that lesson covers and lets you look at it the other way. So you have the choice of which of those two ways you want to use this tool. It's available, it's free, anybody can use it. If you happen to be using any one of the 34 series that we've coded, you would be able to get this kind of helpful information with respect to it. And this then allows the teacher to drive the instruction, because in effect, you pick the standards you want to teach. Unless you want to follow the book, you can also go that way. And I think that's really, really critical as a helpful device. And just briefly, the second part of the system, which we call the journal, is something we use in our own research, and we've now made it available for any teacher to use. You can, if you are willing, after you teach a lesson, you can pull up the journal. It asks you 2 or 3 or 4 or 5 questions: what topic you taught, where it was in the book you were using, etc. And then it takes like 3 minutes, 4 minutes, 5 minutes to fill this out. You can do that daily, and this device will summarize your instruction at any point you want. You can say, how much time did I spend teaching this standard? And it will summarize everything you've done up in the first 4 months. You could say, what did I do over the last 2 weeks? It will produce a graph that shows you day by day over whatever period you choose what topics you covered, so you could actually follow the flow of your instruction. So that's the second part of the device, all of which are available for anybody to use who would like to use those.
Wow, what a wonderful resource, Bill. We're working on getting that posted to the web link box so that folks can have easy access to that. I think people love free, and people love something that's been proven to be useful and effective with other teachers. So thank you so much for sharing that resource with us. It looks like we got it posted there in the parking lot for you all, and we'll also post it in the web links.
We have almost 700 teachers now that have used this system up to this point in time.
Wonderful. So in the spirit of time, I'm going to skip this next poll because it's very similar to the last one we did, and I'm just going to have you kind of synthesize the conversation today, and then we'll wrap up with giving folks one more opportunity to share some thoughts with us, Bill.
Okay. Can you get that to come up?
I can't. So just synthesize the whole thing.
Once again, I think we're losing the connection. So I don't have the slides in front of me, so I'll just have to wing it in terms of what I was going to say at this point in time. I think that the real issues for teachers is how they allocate their time and how they use their time and bring that to bear on these issues. And I think one of the things we're trying to do is put that as a part of the navigator system that would actually suggest to a teacher, you should spend somewhere between X and Y number of days or weeks on that particular topic. I think there are other things that you could do, but it's pretty much a summary of what we've talked about up to this point in time, that there are some of these things that you as a teacher can address. There are some of these things that have to be addressed more at the policy level, and it's a matter then of addressing those things which you have the ability and the capacity to be able to change. I think that for time's sake is probably a fairly good summary. I feel that we've covered most of the issues of what can be done to help you, and I think the key things are the time, the way you use the instructional materials, how you make sure that you're letting the standards drive your instruction, not the textual or instructional materials. Why don't I leave it at that and give time for people to ask any questions?
That is wonderful, Bill. I'm going to get us into this last question. We really want to make sure that this session and this entire series really focuses on action, and we want folks in whatever role they serve in to be able to go back to your schools, your districts, your state, and take some action that's meaningful based on what you learned today. So we're going to be putting up 2 questions into the poll, and know that the ideas that you share could help someone else in the audience, and likewise. So we're interested in finding out from you, what are your key takeaways from today's presentation, and then as a result of today's webinar, what action step or steps do you plan to take? So we'll put those up for a moment, and then let me just look and see if we have any other outstanding questions. You've done a nice job, Bill, of covering a lot of the questions people have had, throughout, and the ones that we received in advance today. One question, and this is something that you maybe peripherally touched on, but this notion of differentiation, and how do we ensure that teachers are able to differentiate for the students in their classrooms? This is sort of a hot topic in general across content areas, and we've recently had this topic addressed by Carol Tomlinson. But do you have any thoughts about how to properly differentiate in math to meet the needs of all the students in the classroom?
Well, I have multiple thoughts about this. You can probably tell from the impassioned plea that I made about tracking to eliminate it, and I think it's just the reason I find it harmful in general to do this kind of differentiation is that it usually has the consequence of hurting those who absolutely need it the most. And I know, it's sometimes children, and one of the people raised it, one of the a 6th grade teacher, I've forgotten her name, I think it was Nicole, said, I have this one girl that can't do that. And those things arise where you have, as a teacher, a very difficult situation. But I don't think the answer for this is really about differentiation. In terms of the lower end, we know that it hurts those students to be given different content. I simply do not find that reasonable, ethical, or acceptable. On the other end of this, you might ask, well, what about the kids that are truly advanced? I think we have a real problem in this country, and you actually have been reading things in the papers which suggest this even extends to sports, where we give ribbons to kids who just are doing an ordinary job. And I think in this arena, kids that are fairly quick at doing some computation, and we call them gifted, and then we pull them off and put them in some kind of a differentiation. I don't find any evidence, and in fact I find much evidence to suggest this is a bad approach, that in fact it hurts students more than it really helps students. And the amount that the best students get in terms of an advancement is so small that it's just not worth punishing the others for doing this. And so I think in mathematics the standards that we have now are challenging, they're accessible to all kids, and that's what should be the case. Now what if you have some kid that really truly can, is smarter, more has a greater aptitude to do mathematics? Well, I once asked my Japanese counterparts why they were studying all these different ways of teaching the same thing. And the answer was really revealing. I said, why do you care about all the different ways of sort of doing the same thing? He says, because that's what we do with the talented kids. We simply keep them in the flow with the rest of the kids, but we take them deeper into the same topics so that they understand multiple ways to do a problem. They get depth, but everybody gets the basic essence of the idea and how to approach those kinds of mathematics problems. And I guess that's my sense of how that would work with the Common Core, because these standards are challenging. They are what all kids need to know. They at both ends that's true. Therefore, it's my opinion, and this is my opinion. The data on the tracking is driven by actual data, but I'm giving you my opinion here, and that is that I think that what I take from those data is, especially in the Common Core era, this curricular differentiation up through 9th or 10th grade has caused a lot of the problems we had. That early graph I showed you with the SES inequality, that's a result of those kinds of differentiations. And I just don't see any data to support that this is a good thing to do. And So I'm not really, you can tell by now, very positive about curricular differentiation.
Well, we value your thoughts, whether their opinions or the research you shared today, Bill. It looks like folks have learned a lot from you. They surely learned that the key message is to think about time and how teachers are spending time. That's one of the key takeaways I'm seeing here. And I'm seeing lots of praise in the parking lot for the information you shared today and for your dedication to the work in this field. So we thank you for that. We're going to get ready to wrap up today. I want to remind folks, I'm going to get these polls off of here so you can see the next couple of slides. If you have questions about the REL webinar series, you can feel free to reach out to me. Or if you have content-related questions for Dr. Schmidt on today's topic, you can reach out to him. And you should see our contact information coming up in just a second. There it is. We would be happy to respond to your questions or comments after today. Like I had already mentioned, you can download the resources that were referenced today below. You can also find today's webinar archive of the entire event. Will be posted to the REL Mid-Atlantic site in just a few days. You should receive an email indicating when that's going to be ready. So I know a lot of folks like to share this with colleagues who were not able to attend today. That's a great way to continue the conversation in your schools, in your district. So please share that and encourage folks to take a look at the materials. We also encourage you all to come back to our next session. We're kind of switching content areas and moving into talking about effective literacy intervention. So whether you're an elementary teacher or if you have colleagues who would be interested in learning more about literacy, please join us at the end of the month for this other interesting topic on literacy. And we really value your feedback. We strive to make this series one that speaks to your needs and responds to what the field needs and wants. So we hope that you'll take a few minutes to respond to the survey and give us your thoughts there. And at this time, we're right upon 5 o'clock. I would like to give a virtual round of applause to Dr. Schmidt. Thank you, Bill, for being here with us today. The folks in the audience seem to have gotten a lot out of it, and I learned a lot. So we're pleased to have you, and thank you again.
You're welcome. It was my pleasure, and I hope it does prove to be helpful. And I again just remind people that to differentiate my opinions from the stuff that is strongly built on the basis of the data. So I don't want to misrepresent when I offer my opinion.
Wonderful. Well, everyone have a great evening, and we hope to see you back again later this month.